All right, so we're going to do one more carbon-carbon bond forming reaction. But this one's different, right? Look at this. This one is making a carbon-carbon double bond. All right, and I know that because I looked at it, right? That's what's going on here. You see that? Now, this is called Alkene Metathesis. Alkene Metathesis. Meta means change, and thesis means positions. And so what we're going to do is we're going to take this guy and this guy, snip, 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 snip. We're going to bond them together, all right, via a catalyst. Now let's tease all this apart. I hope you have your book available, because you're going to find that what could be extremely scary and complicated, we're gonna do some pretty simple things with it. Well, not simple. Simpler things with it. Let's look. All right. So first of all, the catalyst. The Schrock catalyst has a molybdenum double bond, and Grubbs has ruthenium double bonds. Grubbs 1 and Grubbs 2. Right, so first glance at this, you might say to yourself, oh no, I'm dead. I'm gonna have to memorize these structures. There's no way. And the answer is, well, first of all, if you had to, you could. There's lines and bonds here. You could memorize it, but the good news is it's not important, and we're not going to memorize them. We're gonna call this a catalyst, and we're gonna call this a catalyst. Sometimes we'll call it a Grubbs catalyst. All right, and how do I know that? Well, because I looked at the problems, and all the problems that are assigned, that's all that it's called, catalyst or Grubbs catalyst. Maybe Schrock catalyst is used a couple times. I don't remember. All right, so again, don't worry about these, and you don't have to worry about them because you look at the problems that are assigned, and none of them show those structures. Right? Okay. Now, predict the products, all the possible products of this. Now, from the previous slide, let me go back 2 slides. From the previous slide that this guy starts out with him and could end up with either him or him, right? So 1, 2, 3, 4, right? And so 1 double bonded to 3 plus 2 double bonded to 4 could produce 1 double bonded to 3, or 1 double bonded to 2, or 1 double bonded to 4. But then, since that's in the mix, maybe these 2 guys will switch partners, and 1 could end up double bonding with 1. Right? You see that? There's all kinds of possibilities. 2 could double bond with 1. 2 could double bond with 2. 2 could double bond with 3. 2 could double bond with 4. Well, I already have that one in there, so that's not interesting. All right? So you see there's lots of possibilities, and you need to draw them out. Pause the video and draw out all those possibilities. Okay, let me suppose you did, and let me say that one possibility is R1, 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 R2, R2, right? So we got fewer things here, and those are all the possibilities. Now, hold on. This is surely terrifying some of you, but relax, because we're going to see under what conditions would a single product be in high yield. That's what we're looking for. Single products in high yield, or it's not synthetically useful if we can't get a single product in high yield. All right, let's consider this. So first of all, let's talk about this a little bit more, right? Look what we've got going in here. If we got two of these, right, then we're going to get some of this, and we're going to get, right, that's the new double bond that was formed. We're going to get E and Z, and here's the double bond that's broken. Match that guy up with himself, and you're going to get some E and some Z, right? I jumped the gun a little bit on that, where maybe it's the next slide where we're going to talk about how this can be synthetically useful. So, look at this. This is cool. What we do here is we find all the double bonds. There's a double bond. There's a double bond. How many double bonds in this structure? Say it out loud. How many double bonds in this structure? Say it out loud. There are 2 double bonds, right? Because that is not a double bond, remember? Okay, so we got 2 double bonds. So these guys can switch partners, and look at that. Intramolecularly, they can, bam, let's call it carbon 1, 2, or atom 1, 2, 3, 4, 5, and 6, 7, and 0, right? 1 can break up its partnership with 0 and make a new partnership with 7, which would look the same as 0, or 1, right? And there you go. Wow, awesome. Okay, look at this now. See that? If they switch partners again, what are we going to get? Okay, so why are dilute conditions necessary for such ring closings? I've referred to this a couple times in class. Why are dilute conditions necessary for such ring closing metatheses? All right, let's look. I think we only have one more slide. All right, look at this now. If we take this with excess ethene, so we've got a big bath of ethene, Grubbs catalyst, and this is how it's going to show up in the problems. Grubbs catalyst with ethene. What you do when you get something like this, you find, okay, Grubbs catalyst, okay, that's a metathesis. I'm making the notes that I would say to myself, okay, that's a metathesis, aha. So I'm going to take this, snip, 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 and replace these partners. Call that partner 1, partner 2, partner 3, and partner 4. 2 now goes with 3. Oops. There's 3. Here's 2, right? 4 now goes with 1. Okay? Alkene metathesis can be performed in the presence of many different functional groups. So you need to make up many different functional groups. You need to make up problems for alcohols, ketones. You make up one of each of these. That's your assignment. Well, you have your other assignment, right? But you want extra assignments so you can get good at this? There's 6 more problems to make up for you right there. Make up one where you've got ketones, aldehydes, all these things, and show how you can have that this reaction will work. All right. Good luck.